Okay, this is an especially tough question. This is the white blood cell concentration in normal blood is approximately 12,000 cells per cubic millimeter. How many white blood cells does a normal adult have in 5 liters of blood? So I did look up a conversion factor ahead of time. I'm going to show you the easy way. What I mean by the easy way is there's 1 million cubic millimeters in 1 liter. Okay, so that'll represent the easy way, and then I'm going to show you the longer way in case you're interested, but it is kind of the longer way and sort of the more confusing way. Normally on an exam, as always, I'm going to promise that for a question like this, I'm going to try to give the direct conversion factor so there's no issues in this. So how many white blood cells? So the reason why I'm going to start with 12,000 cells is because this is already a count of cells, and the question is looking for another count, except that we have a specific volume in mind. So 12,000 cells per cubic millimeter. And here's where that conversion factor comes in handy. This is a direct conversion, so there's 1e6 millimeters cubed per 1 liter. And that makes things pretty easy because the last step in this setup is 5 liters. And so now what we have is we've got millimeters cubed. Of course, the numbers don't cancel out as always. The liter cancels out, though, and the liter cancels out here. So on the calculator, we say 12,000 times a million times 5 is going to give us that answer we're looking for. I suspect that there's a wrong answer set for this homework assignment, by the way, because nobody seems to be getting the right answer. So that probably means there's a wrong answer. As soon as this assignment stops, I'm going to edit this assignment, fix it to the right answer. Everybody gets full credit, obviously, when in the regrade. And even stuff like this in the answers, you can't do stuff like this, symbols, white blood cells, can't do any of that stuff either. So that'll get it mainly overridden. Okay, so anyways, let's bring up the calculator and see what we get. Okay, so 12,000 times 1e6 times 5 is expected to be a huge number, which it is. And so we've got, holy moly, we've got an implied decimal point right here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we've only got one significant figure. That's because of the 5 liters right here. So I did say 6 times 10 to the 10th cells. And now I know the answer is set incorrectly because I see right here that there's an answer 6E10, which is the correct answer. So rest assured, I'll get this fixed later, but that is the correct answer, 6 times 10 to the 10th. Now, the longer way to do this, and the way we normally teach this in a more advanced class like Chem2A, is, if we don't have that direct conversion factor like I was talking about, we'd still start this off the same. And volume conversions are sometimes really tricky, and here's why. You'll see why in just a second. It's tempting to say that there's 10 millimeters cubed for 1 centimeter cubed, and that is incorrect, unfortunately. So what you have to do when you're doing cubic conversions, and this is, stop this video right now if you don't want to see this, because this is unnecessarily confusing, so we've already got the answer here. But what you have to do is you have to say 10 millimeters, and then you have to cube that whole thing, like so, is equal to 1 centimeter cubed. That's the proper way to treat a cubic conversion like that. Okay, so then another little detail is that there's 1 cubic centimeter for every milliliter. And then there's 1,000 milliliters. And then finally times 5 liters. Okay, so this this value right here, 12,000, already gives us 3 zeros. And then we get another 3 zeros here, and then we get another 3 zeros here, and then there's another 0 effectively for the 12. And so that makes sense that we would normally get 6 times 10 to the 10th. But let's just, I was about to just kind of move along here, but let's prove that on the calculator just to make sure. So 12,000. Okay, I assure you 10 to the 3rd is 1,000 times another 1,000. Then finally times 5. And of course, I believe this is 6 times 10 to the 10th. Let's just check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, so you get the same result. I've made this unnecessarily complicated. This is what I would probably do if I didn't have this direct conversion factor. I'd have to rely on this little, remembering this little detail about cubic conversions. But anyways, 2 ways to solve this. This is the much simpler way, obviously, and we get the correct answer of 6 times 10 to the 10th. Okay, so there's another exercise in dimensional analysis. This was a tough question. This may be actually the toughest question of the entire homework assignment, quite possibly. All right, so that's it for this one.